Alright, you guys, so today um, I'm going to make a few videos on finding the horizontal asymptotes of different functions, because I know that's still super difficult for some of us, and it makes sense because this is a difficult topic. So I'm going to make a few videos. They're going to be crappy just like before, like crappy sound quality, and this like, I'm not going to try making the video super nice or like redo it a bunch of times until I get it perfect, so I'll make mistakes, but bear along with me. Okay, so finding horizontal asymptotes, the first video I'm going to make is just about things that look like this. In other words, it's a polynomial divided by a polynomial. If you're confused what that means, it's just a fraction, and we don't have, like we have x's, but we don't have like logs or powers or anything like that. It's just like some x's, maybe an x squared here and there. Okay, so the key to finding the horizontal asymptotes for functions that look like this is to find what we call, and I'm sure you guys have heard of this in the lectures, the leading term. So what is the leading term of a function like this? Well, it's the leading term of the top thing divided by the leading term of the bottom thing. So let's just look at the top, the numerator. So if I have 4x minus 2, the leading term is just going to be this, right? It's the thing with the highest exponent. And since there's no other x, right, that is our leading term of the numerator. So I'm going to put 4x right there. Now what's the leading term of our denominator? Well, the leading term of our denominator is just this thing, which is 2x. So our leading term of the whole function is 4x divided by 2x. Well, could we simplify that? Sure, so here, let's write it over here. 4x divided by 2x is the same thing as 4 divided by 2, or in other words, just 2. Okay, so what does this mean? If that is our leading term, that means eventually the graph of this thing will look like the graph of this thing. So what I mean is like maybe in the middle it kind of looks like that. Like it won't be that, of course, but it looks like blah 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 in the middle. It looks like stupid. But on this, when you go far enough to the right, it's going to look like the line y is equal to 2. So maybe it goes like, but eventually, if this is 2, it'll start to kind of look like a straight line at 2, right? And then what about the left side? Oh yeah, and same with the left side, right? That means eventually it'll start to look like 2. So as you can see, eventually it gets closer and closer to the line y equals 2. I don't know what happens in the middle. You can try plugging stuff in to kind of get it, but eventually it's probably going to look doesn't look like that at all, but like something like this on the right side and the left side. So we used our leading term to create a horizontal asymptote. So my horizontal asymptote here is y is equal to 2. That's my horizontal asymptote, okay? And I got that just by finding the leading term of this function over here. So let's go ahead and do another little more complicated example, okay? So this time, I have this function right here. I have negative x over x plus 2x minus 2. So again, we just want to find the leading term of this function. But this one's a little harder just because this right here is not is not a normal polynomial. It's factored, right? So we want to get it unfactored first. So I'm going to rewrite this as negative x is over x squared, let's see, plus 2x minus 2x minus 4. Okay, cool. And then if I simplify that, well, plus 2x minus 2x is just 0. So I could rewrite the bottom as x squared minus 4. Okay, so what is the leading term of the top of the numerator? The leading term is just negative x. Sweet. So my leading, I'll put LT for leading term, is negative x over, And my denominator, the leading term of my denominator is this first thing, it's x squared. So my leading term of this function is negative x over x squared. And if I simplify that, right, there's an x on top and bottom, so I can cancel one of the x's and I get left with negative 1 over x. Okay, so what does that mean? That means eventually, maybe my graph looks really weird in the middle, but eventually it'll start to look like the graph of negative 1 over x. And eventually it'll start to look on the left side like the function negative 1 over x. And now our last one was pretty easy because it was just y is equal to, what was it, 2 or something? Yeah, 2. But this one, I don't even know what negative 1 over x looks like, so how am I supposed to know what it eventually will look like? So here's what we're going to do. Let's say, so this is eventually, right? We want to know what happens eventually on the right side. In other words, we want to know what happens if we're plugging in like really, really big numbers for x, right? And also, let's do this in orange. I also want to know what happens to the left eventually, right? So I want to know what happens when I plug in really, really big, like negative numbers, like maybe negative a trillion. I want to know what happens on the right and what happens on the left. So we're going to plug in really, really, really big numbers here into this function, and that'll tell us what this function eventually looks like, okay? So let's just plug in really, 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 really big numbers for x. First, let's plug in a really, 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 really big positive number. So maybe it's a trillion, maybe it's 10 trillion, right? It could be literally anything. Like think of the biggest number that you can think of. Infinity is not a number. Okay, now like bigger than that. Okay, like we're plugging in something huge. So let's try. Let's say we're doing, so let's say we're plugging into here, right? So I have negative 1, and instead of x, I'm plugging in a super, 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 super big number. Like, I don't know, it's just too big. I'm just going to write big, okay? Now, what happens if we have 1 divided by a really, 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 really big number? It's like basically 0, right? Like if you had one piece of, like one pizza, and you shared it with a trillion friends, you're like, basically not going to get any of the pizza. Like you might get like a really, really small crumb, but it's like basically nothing, right? So this is basically 1 over a big, 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 big number is 0, and negative 0 is the same as 0. So my function in the beginning, it's going to be, I don't know, oh, why did my stylus stop working? Okay, it's going to be, but eventually it'll look like this function with big numbers, and this function with big numbers is just 0. So eventually it'll get super, super, super close to 0. Okay, so that's what it's going to look like on the right side. So that's what I'm going to draw. It's like, I don't know what it is in the middle, but eventually it's going to reach the right side. Okay, now we've done, if we plug in really, really big numbers, right? Or on the right side, like really, really big positive numbers. But what happens if we plug in really, 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 really big negative numbers? Let's try that. So we have negative 1 over, actually, I'm going to draw it like this. Okay, sorry about that. So negative 1 over like a really, 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 really big negative number, right? So it might be negative trillion, it might be negative a gazillion, some number, whatever. So the point is, plugging in a super, super, super big negative number. Well, again, so a negative, let's look at this. A negative 1 divided by a negative big number is going to be a positive number. Okay, does that really change much? Not really. Because what was 1 over really, 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 really big number? It's like basically 0, right? So on the right side, or I mean, sorry, on the left side, my function will eventually just kind of look like 0. Like I don't know what it is in the middle, but eventually it's going to look like that on the left side. So that's what negative 1 over x eventually looks like on the right side and left side. So that means my original function will like be like weird in the middle and then eventually look like that on both sides. So let's say you're doing a test And you're like, if I think this is an important concept to understand. But if you're like, gosh, I just need to like know this so I can do it on the exam really quickly. If the leading coefficient, oh, actually, sorry, let me backtrack a little. Okay, so if it eventually gets closer and closer and closer and closer to 0, what's my horizontal asymptote? Y equals 0, right? That was my goal all along. I almost forgot to write that. Our horizontal asymptote is y is equal to 0 because it eventually looks like that on both sides. So now I want us to consider, this video is so long, you guys. I'm so sorry. Hopefully it's useful. Okay, so let's say you're like, okay, I kind of am following this, but like I know I'm not going to be able to do it on a test, or I just need something fast. So here's what you're going to do. If you see that your leading term looks something like that, if there is an x on bottom, right, eventually this thing will be like 0. So I could have like, or x squared, or x cubed, maybe it's a 2 over x cubed, maybe it's negative 2 over x cubed, doesn't matter. As long as it's like a constant on top, you know, like 1 or maybe 5 or something like that, and then the bottom has like x cubed plus or like x squared or something like that, your horizontal asymptote will always be 0. So that's something you can kind of just memorize if that helps you, okay? Cool. So I know this is tough. Rewatch it, ask people for help, ask me for help. I want to make sure you guys understand this.